Hi everyone, welcome to the Exponents review video. Let's go ahead and get started. On problem 1, they ask us to simplify 5 times into the negative 1. Now, remember, this negative 1 exponent does not apply to the 5. So we really have 5 times n to the negative 1. Now, because this n has a negative 1, we need to switch it. So this becomes 5 times 1 over n to the positive 1. So when we send the n downstairs, the exponent then becomes positive. When we multiply this out, it becomes 5 over n to the positive 1 power. And remember, you don't have to write the positive 1 power. It's assumed that it is there. On number 2, we need to recognize that there's a 0 power by the x. And that 0 exponent, anything raised to a 0, is 1. So we really have 5 times 1 times y raised to the negative 3 divided by z raised to the negative 3. So these negative exponents we really need to get rid of because we can't have negative exponents in our answer. So what do? We switch it. So 5 times 1 is 5. This y to the negative 3 needs to go downstairs and becomes positive. And this z to the negative 3 comes upstairs and that becomes positive. So our final answer is 5z cubed divided by y cubed. Number 3, they're asking us to evaluate a raised to the 0 power times b to the negative 2 for a equals 4 and b equals 5. So we're going to plug in 4 wherever we see a and 5 wherever we see b. So it's going to be 4 raised to the 0 times 5 raised to the negative 2. Now remember, anything raised to the 0 power is 1, so this is 1 times, and now this negative 2 exponent, we don't like negative exponents, so we have to switch it. So it becomes 1 over 5 raised to the positive 2. So this becomes 1 times 1 over 25, which is just 1 over 25. All right, next section, we are multiplying. And remember, when you multiply the same base, you add the exponents. So on problem 4, we are multiplying x cubed times x to the 6th, and we have the same base of x, so we are going to add our exponents. So we'll add 3 and 6, and this becomes x to the 9th. So on number 5, we're multiplying 4 times a to the negative 3 times 5 times a to the 7th. So first thing we're going to do is multiply our coefficients, 4 and 5, and that gives us 20. Then we're going to multiply our a terms, and whenever we have the same base, we add the exponents. So this becomes a to the 4th, because negative 3 plus 7 is positive 4. So our answer is 20 times a to the 4th. The important thing to remember that there was that you multiply the exponents, or sorry, not the exponents, I'm sorry, you multiply the coefficients, and then when you're multiplying things on the same base, you add the exponents. Do not add 4 and 5. I think that was a mistake that I've seen quite a bit. On number 6, we'll do the same thing. We multiply our coefficients, and then we'll multiply our x terms, and then we'll multiply our y terms and our s terms. And when we multiply our coefficients, we end up getting 36. 3 times 2 times 6 is 36. And when we multiply x to the 5th times x squared, it's the same base. So we add the exponents and it becomes x to the 7th. And then our y and s term are by themselves, so we just bring those down, y to the 7th and s. So our final answer is 36 x to the 7th, y to the 7th times s. All right, moving on to the power to a power problems. Here we have an exponent raised to another exponent, so we call that power to a power. And we have to power up and multiply our exponents. So here we're going to multiply the 4 and 5 to give us 20. So my answer is x raised to the 20th. On number 8, we have 2 raised to the negative 4 raised to the 3rd. So we have a negative 4 raised to the 3rd power. So we power up and multiply our exponents to become 2 to the negative 12th. Now, we can't have negative exponents in our answer, so we have to write it as 1 over 2 to the positive 12. And if you enter that in your calculator, I believe it comes out to be 1 over 4,096. I'll accept either answer on your test. Okay, so on number 9, we have a power to a power problem. So we distribute this 2, we power up, and we multiply. Now this 3 has an exponent of 1 in it, of 1 on it, that you need to recognize. So if we imagine a 1 there, we're multiplying this 2 by each one of those exponents. So we get 3 squared times x to the 6 times y to the negative 8. Now, 3 squared becomes 9. X to the 6 is positive, has a positive exponent, so it stays put. But the y has a negative exponent of negative 8, so we have to switch it and send it downstairs to become positive. So we have 9 times x to the 6 over y to the 8th. Moving on to the dividing problems. Here they're asking us to simplify 15m to the 6 divided by 3m. So we divide our coefficients first, 15 and 3, and then we'll divide our m terms, m to the 6 and m. Now, when we divide our coefficients, 15 divided by 3 gives us 5. And then when we divide m to the 6 by m, we are dealing with the same bases but different exponents, so we subtract and we get m to the 5th. So, dividing, you get the same base. If you're dividing by the same base, you subtract the exponents. On number 11, they ask us to simplify x to the 5th times y to the 9th by x squared and times y to the 12th. So I'm going to divide x to the 5th by x squared and y 9th by y to the 12th. Since we're dealing with the same bases, we subtract the exponents, so you end up with x to the 3rd times y to the negative 3. And we can't have negative exponents, so we have to switch it. X to the 3rd stays put. It's got a positive exponent. But y to the 3rd needs to be switched, so we send it downstairs to become y to the positive 3. On number 12, we have simplify 3 raised to the 0 power, which we should automatically know is 1, because anything raised to the 0 power is 1. Number 13, we're simplifying the product, so we multiply our coefficients, we multiply our c terms, and then we multiply the d terms. And when we do this, you end up with 2. And then when we multiply c raised to the 4th times c, you get c to the 5th. And when you multiply d to the 7th times d, you get d to the 8th. And that is your final answer. On problem number 14, we're comparing quantities in column A and column B. And the quantity in column A is the exponent of x when x cubed times x to the negative 1 times x is simplified. So here we are multiplying things of the same base together. So we just need to add the exponents. And this becomes x to the 3rd power. Because 3 plus negative 1 plus 1 is 3. So the quantity of column A is 3. It's the exponent of x when x cubed times x to the negative 1 times x is simplified. In column B, they want the exponent of x when x to the negative 3 times x to the 7th times x to the 6th is simplified. So we're multiplying things of the same base, so we add the exponents. So this becomes x to the 10th, because negative 3 plus 7 plus 6 is x to the 10th. And they want the exponent value, so our value in column B is 10, and therefore B is our answer. The quantity in column B is greater. In problem 15, it says the area of a rectangle is 5 times a squared times b cubed, and the width is 3 times a times b. Find the length of the rectangle. Well, the area of a rectangle is equal to the length times the width. So if we want the length by itself, we're going to go ahead and plug in. The area they gave us is 5a squared times b cubed equals the length that we're searching for times the width of 3ab. In order to get L by itself, we have to divide both sides by 3AB. This cancels out, and the length ends up being equal to 5a squared b cubed over 3ab. Now we're dealing with properties of exponents and dividing problems. So we're dividing our coefficients, our a terms, and then our b terms. So you end up with 5 over 3, and then because that cannot be reduced, and then when you divide a squared by a, you subtract the exponent since you're dealing with the same base, and you end up with a to the first, because 2 minus 1 is 1. And when you divide b cubed by b to the first, you end up with b squared, because 3 minus 1 is 2. So your final answer is 5 times a b squared over 3. And that is your final answer. On problem 16, they want to find the area of the rectangle. And remember, area formula for a rectangle is length times width. So we're just going to plug in. Our length is 3 times x to the 4th y squared times xy. And when we multiply, we're going to multiply our coefficients, which in this case they're 3 and then 1. That's assumed to be there. And then our x terms, and then our y terms. So we end up with 3 times x to the 5th, because we're multiplying the same base. X to the 4th times x to the 1st is x fifth. And then y squared times y is y to the 3rd. The important thing to remember is that if there's not an exponent written somewhere, it's 1. Okay, problems 17, 18, and 19 are review problems from our Unit 8 test over equations of lines. In problem 17, it says that the linear parent function is translated down 5 units. Write the equation of the line. Well, the important thing to remember is the linear parent function is y equals x. And if you notice the y-intercept, if we're looking at slope-intercept form of y equals mx plus b, the b value does not exist in the linear parent function. There's no number added to the x term. So therefore, the y-intercept is 0. And they want an equation if this is translated down 5 units. Well, when you translate a line, it doesn't change the steepness. So the slope here is not changing, but if you're moving it down, the y-intercept will. So the y-intercept in this case is going to go from 0 to -5. So we write it as y equals x, and then our new b value, our y-intercept, is -5. So our equation is y equals x minus 5. On number 18, they want us to write an equation in slope-intercept form. Well, the important thing is to remember that slope-intercept form is y equals mx plus b. Of the line that passes through the points 2, -4, and 5, 6. Well, we need to find our b value and our m value. And we have to find the slope first, and we know to use the slope formula, y2 minus y1 over x2 minus x1. And when we plug in y2, and then let's go ahead and label our points actually as x1, y1, x2, y2. And let's go ahead and plug in. So it's 6 minus -4 is really plus 4 over 5 minus 2. Remember, when you're subtracting a negative number, it becomes positive. So we end up with 10 over 3. So my slope is 10 over 3. And now we have 2 ways of solving for our equation of a line. We can either use the point slope method or the butterfly method. I'm going to choose to use the butterfly method, which is m equals y minus y1 over x minus x1, and then we'll cross multiply. So this gives me m equals y. Oh, sorry, we can plug in for our m since we solved for it. M is 10 over 3. And then we have y minus y1, which is minus -4. So that becomes positive 4 over x minus 2. We draw our butterfly wings, and then we cross multiply inside of our butterfly wings. So we have 3 times y plus 4 equals 10 times x minus 2. And you end up with 3y plus 12 after distributing the 3. and then we distribute the 10 to get 10x minus 20. Now in slope-intercept form, the y is by itself, so we need to get y by itself now. So we subtract 12 from both sides, and you end up with 3y equals 10 minus 32. Then we divide everything by 3, and you end up with y equals 10. Oh, sorry, there should be an x there. It should be y equals 10x, 10 over 3x minus 32 over 3. All right, last problem. They want us to write an equation in point-slope form. When we pause, you have to remember what point-slope form is. Y minus y1 equals m times x minus x1. And it has to pass through the line of negative 2, 4, and has a slope of 1/2. So our point is negative 2, 4, so negative 2 is my x1, and 4 is my y1. And my m value, my slope, is 1/2. So now all we have to do is plug into our formula. Y minus y1, which is y minus 4, equals m, which is 1/2, times x minus x1, or minus negative 2 becomes a positive 2. So that is our equation in point-slope form. Now, I will be here at 6:45 in the morning tomorrow for any last-minute questions. I hope this was helpful. And just remember that you'll also have your STAR reference sheet, which will have formulas such as the slope formula. It'll have the slope-intercept form written on it and the point-slope form written on it. So many things like that will be on there. So make sure that you use that wisely tomorrow, and I'll remind you of that again. But I hope you have a great night of studying, and I will see y'all tomorrow. Good luck, y'all. Bye.